Hello everyone, I am Glenda Tan. Today, I'll be sharing with you my project, Computer Vision Object Tracking Robotic Car for ADHD Children. This project was inspired by my little cousin who has ADHD. His teacher constantly scolded him in class for daydreaming. He would walk around his classroom aimlessly, tapping his fingers and talking non-stop. This affected his learning. My cousin threw away the jewelry that my aunt gave him as he found it too childish. He also lost interest in fidget spinners and toy cars as they cannot respond to him. I was determined to help him and thus embarked on my invention journey. From literature review, I found out that ADHD is a neurodevelopmental disorder. According to the Academy of Medicine Singapore, the worldwide prevalence of ADHD is 5.29%. In Singapore, 500 ADHD cases are diagnosed annually. ADHD is the fourth largest contributor to disease burden in children aged 14 and below. Existing treatment cannot cure this chronic disease. They can only deal with symptoms. To help my cousin manage his ADHD symptoms, I decided to create a computer vision object tracking robotic car that he can control and interact with. Now, I'll be sharing with you my design thinking process. Firstly, I planned and selected the hardware components sourced online. Initially, I could not find a compatible bracket for my camera. I had to design and 3D print one on my own using SketchUp so that it could be mounted onto the bracket. Next, I designed and drew the circuit diagram for the robot. Then, I assembled and wired up the components. Now, for the software. I wrote a color detection algorithm to detect the red ball. First, the algorithm will scan the image pixel by pixel and compare it to a color threshold. If the RGB value is within the threshold, it is considered as red, else that pixel is ignored. I then use the find blocks function to detect binary large objects, regions of the image that are red in color. This is my red ball detection implementation in MicroPython. When I tested the camera, it mistook my arm for the ball. I realized that my thresholds were too close to beige, so the camera detected my arm instead. After modifying the threshold so they are closer to red, the camera could detect the red ball. I wrote a PID controller algorithm for the robot to track the ball smoothly. First, the Arduino receives the ball's X coordinate from the camera via serial. Then, the error E and the P, I and D errors are calculated using the equation shown. The P term affects how much the robot should turn to face the ball. The larger the error, the larger the correction. The I term enables the robot to correct an accumulated error. For example, if the robot is constantly too much to the left, it will turn right. The D term is the damping term which prevents the robot from overshooting. The final correction is passed to the motors for the robot to turn and face the ball. This is my implementation of the object tracking function in C. After the robot was completed, I tested it. This is the ball detection function in action. You can see the camera's captured frames on my computer. Then, I tested the object tracking function by moving the ball left and right and forward and backwards. It works! When my cousin tested the robotic car, he was very happy that it could respond to his movements. This is a video of him rolling the ball and the robot chasing after it. Interacting with the robotic car has helped my cousin sustain his attention and he can now concentrate better in class. I'm glad that my invention has helped him to manage his symptoms better. When the COVID situation stabilizes, I hope to share my invention with other ADHD children so they can also benefit from it. Thank you!